All right, real quick, we're gonna try to answer this question, create a box plot, and then tell us what the box plot. I mean, there's a lot of questions about what a box plot shows, but we'll just first just look at it. So I've already filtered my data, 60 to 65 employed individuals, and I want to create a box plot. So I go to plots, go to box plot, I select my variable, wages. I'm not going to do a group by. Now I could do vertical, but it's really, you can see it, very difficult to see what's going on there. So it's much better to do horizontal, I think. It lays it out a little, you can see it better. And then and we ask, what are we seeing here? Well, obviously we see these outliers over here. There's another feature that you can do. Some people like to do this overlay points. It starts to get a little crazy when you have a lot of points. Like we have 16,000 points here, so it's pretty insane to look at. I don't know if you remember earlier when I was doing this problem, I was like, maybe we should have moved the wages to $1 because we had a lot of zeros. That seemed to me a good idea. Um, we can try that again. One thing that it does is it doesn't remember the orientation for some reason. So if we go to box plot, variable, wages, and horizontal. And we could overlay points, but I think you'll see that the overlaying of the points, it's nice for the outliers because instead of seeing just one or two dots, you actually get a sense of how many outliers there are, and you can see like there's nothing in here. So you're like, well, why is there this big vastness right here? It's not really. It's the way the data is done. Once you get over this particular threshold, 390, then you become the outlier. So these people here, they're not all making 627. Some are making maybe 500. Some are making 700. This is the average of all of the outliers in the state of California. We see a lot of, so you can kind of get a sense of the density. And nice thing to know about the box, I mean, it's nice to see the dots. I don't think they're needed all the time, but when you're first trying to understand a box plot, it's not a bad idea to have the dots, because what you see is there's quite a density in the first, when you go from this 0 to 75,000. There's a lot of people in that range. You can see that's the most dense range. You would also see that in the histogram. Maybe we should go back and look at the histogram as well, because really these two play off of one another. We'll look at a histogram real quick too. Although I know this is not necessarily the skill that we need here, but I think we started this at 0 again. I think I ended up doing 10,000 here, and we went all the way to 700,000. There's that density that we're talking about. Density, when I talk about density, it's like how many dots are there in that area. So we come back to this. There's a lot of density here, and you can see it starts to fade out here. And what we're seeing is here we have like the bottom 25% is really tightly packed between 0 and 37,000. It's a little hard to see the 37,000 there. And then it stays pretty consistently thick until we get to 75K. Now, does that show up here as well? I would kind of think so. So here's 75K right about here. So density is pretty high. The highest density is in this 30 bandwidth. I don't think you're going to notice that in the histogram, that it's really dense in the 30 region. Maybe. It looks a little dense there. It's like the darkest, not as much white there. So you see this is all pretty tight, and then when you go from the median, which is this median line, we're at 75,000. That means 50% of my sample makes less than 75, and then the other 50 makes more than 75. So that's all of these dots are 50% of the data. All of these dots are 50. It looks a little bit misleading, but this is spread out quite a bit. One thing that we do notice here so we do have our box. If the data was really symmetrical, we would see that the center of the box would be, or this line that's in the middle of the line that's inside the box, you would expect it to be in the middle. It's a little shifted to the left, meaning there's a little greater density of 25% here than there is here. It's a little more spread out. It's taking more dollars. It's taking a longer length to get the same amount of 25% of the sample. And then you can see there's a really big spread of the final 25%, because here's Q3 at 133,000, and then you can see there's these people they're very spread out. So the top 25% of earners have a lot of variability, but the bottom 50% has very little variability because they're only varying by 75,000. But there's a lot of variation in this upper quarter, which is typical when we see a right-skewed data set. Right-skewed data sets will have a lot of variation in the upper portion of the distribution. It's not always the top 25%. Sometimes it's maybe only the top 10. But here we're seeing that we're getting a lot of spread once we kind of pass that threshold of the Q3, and it gets spread out more and more. So again, the question says, well, what's the middle 50? So we don't always need to see all that. It's a lot easier to look at this graphic. And actually, when box plots were originally created, they were drawn by hand. No one was making a lot of dots. They were just finding Q1, finding Q3, finding the median, and drawing a box. And later they introduced these whiskers, the right whisker and the left whisker. They're sort of arbitrary. I don't get too caught up in what these whiskers mean. These whiskers are where we would sort of expect data to lie if our data didn't have any extreme measurements. And when they say, it's basically like you take the width of the box, and it's usually like 1.5 times the width of the box. So I don't know, our width of the box it's about 100,000 is the width of the box, and then the distance here you can see it goes from 133 to 276. So you got 100,000 here. If you go 1.5 times that, it's like 1 in 150. It's almost that. It's like 143. So there's little different formulas. Every computer does it. And you say, well, why isn't this so? Why is the left side not as long as the right side? Well, the left side can't go any further because it's going to hit 0. We're not reporting negative wages. That means you paid someone to go to work. That doesn't happen, I don't think, too often. All right. I think that's pretty good here. All right.